Good morning, Geometry Honors students. So Mr. Chen again. So today I would like to talk about sections 11.3. So this one, it's basically all the area of a regular polygon. So objective, find the area of equilateral triangles and find the areas of other regular polygon. So record that the area of a triangle, it's always 1/2 times the base times the height. Okay, so if you do have a triangle here, so it's always the base times the height and then divided by 2. So the area of a polygon. So let's say we do have a pentagon. So the way to do it, it's about 1/2 times the apothem. So the distance from the center of the polygon to the midpoint of one of the base, it's called the apothem. It's just like the height of the triangle. And then the base. So we do have 1, 2, 3, 4, 5 bases. So we need to get through the perimeter. So you might be wondering what this one is. So this one basically just generates that the area of all the triangle. So if that's a pentagon, so we do have 5 congruent triangle. Okay. So once you generate all the area of those triangle, and then we'll get the area of this polygon, pentagon. Okay, so now check it out for this one. So find the area of a given equilateral triangle. So we do have a base of a triangle which is 5√3. So we do know that's equilateral. So that means each one of this angle is considered 60 degrees. So take half of this. Well, the half, which is what? It's an angle bisector, which is the height of this triangle. So we do have 30, 60, 90 degree triangle. So half of 5√3, then that would be 5√3 over 2. So using the special ratio, so 30, 60, 90 degree ratio with the special right triangle, we do have 1√3 and 2. Or 1x, √3x, 2x. The shortest segment it's given, so x is given. So in order to get the height, it's just √3 times 5√3 over 2. Then that'd be 5 times 3, which is what, 15? 15 over 2, or 7.5. So once we get the height, we get the base, so we can get the area of the triangle. So 1/2 times 5√3 times 15 over 2. So 2 times 2, that's 4. 5 times 15, so 75. So 75√3 over 4. And the unit, this one there's no unit. You can stay that square unit if you want. Okay, so now the next one. So given a hexagon, so 6 sides. So n is 6 with a radius 10. So the radius is from the center to the vertex to one of the vertices of the polygon. So the apothem is still not given. Okay, so the apothem would be this one down here. The apothem, it's always the distance from the center of the polygon to one of the midpoint of the base. Okay, so here's the apothem. Okay, so get the length of one side, so 10. So this one, we do know that it's hexagon. So we do know that this angle here, if we go around, is 360. So 360 divided by 6. So we do have 60 degrees. So that means this angle here would be considered 60. So half of 60, then that'll be 30. So if we zoom out, that the half of the right triangle here, half of the triangle, it's a right triangle. So this one would be 30. Down here would be 60, and then this one's 90. So we do know that the radius is given, so it's 10. So the longest leg is given, again, using that the special ratio, so 10 divided by 2, so we got 5. 5 times 3, √3, so 5√3. So we'll get the apothem. So the apothem would be considered 5√3. So one of the sides, so half of the side, it's 5. So that means the entire side length here, then that'd be 10. 5 plus 5. And then to get the area, using that the formula, 1/2 times the apothem times the perimeter. So 1/2 times 5√3 times the perimeter. So each side is 10. So 10 times 6, which is 60. Or you can just, simplify the first 2 goes into 10 5 times. So 5, 5, 25 times 6, which is 150. So 150 √3. So 150 root 3 unit, again, there's no unit. You can state that as square unit or just leave it with the number. Okay, so again, it's all about using the special right triangle. Okay, so now let's see what else. Find the apothem for the regular octagon. Okay, regular, that means all sides are equal. Okay, so that's why I put a little tick mark here. So again, the base is already given. So right now, we just need to get the apothem. So the way to get the apothem, again, so using that the round circle here, so 360 divided by 8. So this one divided by 4, top and the bottom. So we do have, well, divide it completely. So 360 divided by 8, which is 45 degrees. So that means this angle here, the vertex of this zoom out triangle here, so it's 45 degrees. So half of it, then that'd be 45 over 2, which is 22.5 degrees. So this one is 90. So we do know that half of the base here, half of 12, which is 6. So in order to get the apothem, so we can use tangent. So the ratios of tangent, so tangent of 22.5, so which is considered opposite over adjacent, so 6 over 8. Solve for the apothem, so this one you can cross multiply or just swap those terms. So we got A equals 6 over tangent of 22.5 degrees. So once we get that, the apothem, so we can get the, well, this one just find the apothem. So basically that's what we have to do. So plugging that to the calculator to find out exactly what that is, or simply just leave it as the way it is. So using this one, it's a non-special right triangle, so we're using SOHCAHTOA because that's a right triangle, so cosine, sine, or tangent. So this one involved with opposite over adjacent, so that's why we're choosing tangent. Okay, so now let's see what else that we have. Find the area of the shaded region. So this one, again, it's an equilateral triangle. Okay, so all sides. Okay, so this one, yeah, this one's supposed to be given as an equilateral triangle or equiangular because you see that all those angle here, so it's being highlighted with a single R. Okay, so the things that all three sides are congruent, so let's find out the area of the equilateral triangle just like what we did before. So this one would be the height. So take half of that triangle, so we got 5. This one would be 30, then this one would be what, 60. So using the special right triangle, so the height would be 5 root 3. So find the area of the triangle first. So 1/2 times the base, 10, times 5 root 3. So the way to find out the entire area of a triangle, so that one is pretty straightforward. So this one is just like 25 root 3. But the problem is that how do we find out the area of that perfect square in the middle? The bounded inscribed perfect square. So the way to do it, so here's what we need to set up. So let's say that this one, it's the side of the square, it's x. Okay, so the side of the square, so let's say that it's x, 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 and x. So the bottom base, so this one is the total length is 10. So 10 minus x divided by 2. So we'll get the base of this triangle. We got a base of this triangle. Because once we subtract, we'll get the rest of the segment divided by 2, because this one is considered congruent, divided by 2. Okay, so once we get that, so we do have another right triangle here, this right triangle. So the base here is 10 minus x over 2, and the height here is x. Again, this angle, we do already know that it's what, 60 degrees. So if this one is the case, so that means we can apply the ratios of tangent. So tangent of 60. So using that, the right triangle, so tangent of 60, root 3, 1, 2. So tangent of 60, which is opposite over adjacent, so it's root 3 over 1. So we got root 3 over 1, so we can set it equal to this triangle here, opposite over adjacent, so x over 10 minus x over 2. So this one's a lot of things we need to think about. Okay, so we can do cross multiplication. Okay, so what we found here is root 3 over 2 times the quantity of 10 minus x, numerator times the denominator, and then the other side here is just 1x. And then what we can do next, we can distribute, so it's root 3 over 2 times 10, which is 5 root 3, minus root 3 over 2 times x, so that equals x. Okay, so now let me get more space here, so let me get rid of this triangle. So what we can do here is solve for x. So we'll try to isolate the variable. So bring that negative root 3 over 2x from the left side to the right hand side. So we got 5 root 3. So that equals x plus root 3 over 2 x. So using that x as the greatest common factor, so we got x times the quantity of 1 plus root 3 over 2. So 5 root 3. And then from here, divide it. So 5 root 3 divided by 1 plus root 3 over 2. And you might be wondering things that we can simplify a little bit more. So we can multiply that, the least common denominator, top and the bottom, multiply by 2, then distribute. So we got 10 root 3 over 2 plus root 3. So once we get the value of x, so what we can do, find the area of the square. So the area of a square, which is x squared, so 10 root 3 over 2 plus root 3 quantity squared. So this one turns out to be 100 times 3, which is what, 300. Exponent, distribute that top and the bottom. Denominator, so try to expand it, so that would be 4 plus 2 root 3 plus 3. And then combine that 4 and 3 together, you'll get what, 7? 7 plus 2 root 3. Okay, let me just... So 7 plus 2 root 3. Okay, let's put it this way. And obviously this one you can simplify it, but we just want to keep it as the way it is so far. And now we got the area of the equilateral triangle. We got the area of that perfect square. So now how to get the area of the shaded region? Finally, that's right, subtract. So 25 root 3 minus 300 over 7 plus 2 root 3. And then you'll get the area of the shaded region of this equilateral triangle. Okay, so let's put it this way. So this one, it's a little bit more rigorous. A lot of things that you need to worry about. Not just getting the area of the triangle, the equilateral triangle, but also getting the area, finding out the area of the perfect square. Okay, so any questions that you have for this part of the lesson, so please, you're more than welcome to rewatch the video, or fast forward, or just rewind back to the part of the content that you kind of struggle. Okay, so once again, thank you for watching it. So I'll see you guys next time.